All right, you guys ready? So thank you for joining and coming to my talk today. My name is Federico. As you can hear from my voice, I have a bit of a sore throat and a bit of a cold, so this is not my normal voice. But we're going to go through it. That will not stop us. So I work for a company called TransferWise. We're a fintech startup. Company's public now, so it used to be a startup. It's a scale-up now. Based in London in the UK. I used to work for consulting companies across London, the UK, and Canada. My background is in financial services and consultancies. So today, we're going to talk about software supply chain security. Why are we talking about that? We're talking about that because it's getting more and more attention in the industry, in the market. I'm sure that most of you must have heard about this. So just to see where we are with that, okay, I'm just going to ask you guys to raise your hands if you have heard of software supply chain security. Can you please raise your hands? Okay, most people in the room. Who here has heard of some of the attacks that took place over the past couple of years related to software supply chain security? A few people more, like maybe like 20, 30% of the room? Okay, it's a good gauge, right? We're seeing this getting more and more attention. Who is looking at this in particular? Well, everybody, I'd say. So from 2021 onwards, we've seen that across the globe, from the US to the UK, Germany, NATO, like the EU, everybody's looking at this and saying, it is getting a bit of a problem. We have to regulate that. The IT industry has not been able to self-regulate this, so we have to look into this. So a number of laws, legislation, and frameworks came out and said, this is an important topic we have to talk about, okay? So not only we have this connection between software supply chain security and legislation, but we have a connection also with SALSA. Okay, SALSA is a framework for software supply chain security, and since 2022, we've been able to draw a connection between companies who are good at securing their software and companies who make more money. So this is the other thing. You're looking at this topic from a compliance, security angle. We're looking at this topic from a revenue angle. This is a revenue generator. It's very interesting. Companies that are good at security are making more money. The companies that are not as good at security. It's a very interesting find. So the ecosystem has a big role in this. But I want to keep it engaging for you. I don't want to just like blurb a whole bunch of like, here is a whole set of things you have to do. We'll have that, but I want to tell you some stories first. So story number one. SolarWinds attack, 2020. Who has heard of this attack in 2020? Only a few people. So let's talk about this. This is a supply chain attack in which a set of attackers, we'll just call them, were able to break into this company called SolarWinds and take control of their build system. They were able to manage to take control of their Jenkins, their Circle CI, their build system. They take control of it, and then they were able to inject code into an application that SolarWinds was developed. So now you have code in this package app, signed. Then they're using the software updates mechanism that comes with it to push the update to all the users globally of SolarWinds. Orion, I think, is the customers that were getting installed there. So look at what is happening. Cracking the build system, attaching something, signed executable, pushed to the normal software update cycle, lands on people's desktops, stays silent for 14 days, so does nothing for 14 days, and then afterwards connects to a command and control server. So this is really clever, right? It's a very advanced attack where you have this being pushed out. 20,000 companies affected. Microsoft downs the command and control domain, so the malware is rendered ineffective, but it is still a big deal. Log4j, this is a very popular one. In 2021, December 2022, there's a vulnerability that was discovered in Log4j that allows for remote code execution. Each Java application that is using Log4j, which is like probably the majority of Java applications, can now be exploited from remote, right? So this is a very big thing, but it's a very different type of attack. There are no attackers here compromising anything. It's just a open source software vulnerability. It's a big one, though. Let's just go ahead on our attack journey, if you want. Let's talk about something else, even browserify brandjack. This is a NPM attack. Who here has heard of the last npm's attack of the past couple of weeks, right? Few people. See, 2 attacks in the past couple of weeks. More. So this was one of the initial ones, but it is a similar thing. Because there's no dependency control there, or it's very similar to typo squatting. Because there's no dependency control on npm, people were able to register a package with a very similar name to a popular package, and then trick developers into using the wrong library. Once again, this is an attacker with a malware. He's not compromising anything, but he's just registering a package with a similar name. So, and then sending emails, can you please download this package? It's getting very interesting there. But it's a different category of attack. And then another attack on npm got quite famous. In this case, an author of a popular npm library on npm called ColorJS and Faker.js, these libraries were allegedly corrupted by the maintainer himself that was protesting against the lack of monetization of the open source. You people, 27 million downloads every week. People are compromising, are using this application, and nobody's paying for it. So I, as a maintainer, change the source code and create this sort of like loop that happens in source code and effectively break people that are using the app. So very interesting. Similar to PyTorch, namespace confusion as well. Another attack that we're seeing here. More and more of these attacks where people were abusing effectively the lack of controls on Python, PyPy, package manager, once again, in the supply chain. All of this is sort of like some types of attack. But I want to ask a question now. Who has heard of an attack on something called XZutils? 3, 4 people, 5 people? Okay, a few people, but I want to tell you a story then. Listen to this story. It is November 2021. Okay, November 2021. A GitHub user called GiaT75 creates their account on GitHub and sends a few comments to this library called XZutils. Library is an open source library that is used for data compression within Linux. Everything stays there, no problems. 5 months later, March 2022, GiaT75 starts engaging with the community and starts saying, I want to become a maintainer. I want to become a maintainer. The existing maintainers are resisting this a little bit. So you see this effectively social engineering practice, effectively this large number of messages that are sent to maintainers by other users saying, hey, we need more features from you. We need more features from you. Why don't you let more people contribute to the source code? Okay? So very interesting. Somebody says, can I please contribute? Maintainers are like, maybe not. And a whole bunch of other people say, maintainers, you need to be more flexible on the mailing list. Time passes. January 2023, a year and a few months later, Tia manages to become a maintainer on the project. 6 months pass. June 2023, so from November 21, June 23, Gia commits some source code in the library by itself that is just used to test the library and changes this testing library. Time passes again. We get to July 2023. Gia contributes to a different library that is used to test this one library and disables some of the checks of the second library that is used to test the first one. February 2024, almost 2 years after, Gia contributes directly on the library XZutils, code that is a backdoor code. So this is a clear code that is used for backdoors. This is clearly, at this point, is being malicious. Turns out that this library is part of OpenSSH. This is why it was important. So in March 29th, 2024, software engineer notices that this specific library is using a lot of CPU time and says, oh, why is this part of OpenSSH is taking so much CPU time? Notices it and says, oh, okay, there's complexity here. What is happening? Somebody was able to crack OpenSSH effectively, to inject a vulnerability in OpenSSH that could be exploited from outside. This is a 4 stages process with extraction, several bash script, and a hooking function on modeprobe on the Linux kernel. So this is a very advanced attack. Through almost 2 years and a half in the making, right? compromising a library that is used by OpenSSH, and this was done by somebody or maybe a set of people that took a very long time to do it. This is not an easy thing. It's not something that a single person does. This is a clear activity that was done by some organizations. We still don't know today who has done it. But the interesting thing is, it is an advanced type of attack, okay? Okay, so one more attack before we go into our frameworks exploration thing. This is a more 2025, 2024 AI attack. So listen to this. You go to your AI assistant, you go to ChatGPT, to your Copilot, whatever, and say, hey, I have this problem. Can you please create some source code that solves my problem? Can you please create, I don't know, like a website that gives me all the information on Belgrade? Whatever that is, right? You go and you do it. And we know that these AI assistants hallucinate oftentimes. So they respond with a whole bunch of source code that says, this is the solution. And the source code uses maybe 4 or 5 libraries. But one of them doesn't exist. It's an hallucination. It is just a hallucination of the software. So you say, OK, cool, hallucination, whatever. I recognize it because the library doesn't exist. Turns out that the hallucination of the assistant are statistically predictable. So if I go and ask different questions, the assistant will hallucinate in a very similar way. Will always generate a library with the same name. The library doesn't exist. It's an hallucination. But researchers say, what if we create the library now? Okay? So some researchers created the library that was being hallucinated by OpenAI, ChatGPT, and the result was 30,000 downloads, and the library being used across 20,000 companies, I think. It's a very interesting thing, right? So this is just being clever about how LLMs work. Once again, a different type of risk, though. We've seen risks that were clearly connected to an attacker and specific to an organization. We've seen risks that were connected to AI. We've seen risks that were coming from just open source vulnerabilities being exploited. So very different type of things. We have different categories of problems. The big question is, how do we solve all of these classes of problems at the same time? We know that we have to secure our supply chain infrastructure. No doubts about that. How do we do it, though? Because the supply chain of the software is very long, right? It starts from, if you think about the SolarWinds, it starts from procurement. Which software am I going to buy? From whom? Do I trust the source of the software? All the way down to deployment in production. Can we use the software in a secure way and run it in production? This is a very long chain of things that happen, okay? We, in this talk today, we're going to focus on developer, building some source code, building it with some dependencies, and packaging it. This is the focus of our conversation because we're technical people, and we're going to talk about technical problems. But the supply chain software, the supply chain of the software is super long. Think about that. And don't forget that there is a number of things that are not in the talk, but are really important, right? For example, background checks when you hire people. For example, physical access policies, security. So all of this is really important. If we want to protect ourselves from the GI T75, the GitHub contributors creating problems for us, the solution is as much having a peer review of all the PRs that are coming into the source code as much as doing background checks. So this is just information. Maybe the first takeaway of the session is to think about, we have to think about this problem holistically throughout. So the industry said, OK, I have a problem. I'm going to build some frameworks. Microsoft has created one, CIS benchmarks, saying here's how you're securing it. We have Cloud Native Computing Foundation creating one as well. But the most famous framework that tells you how to secure your builds and verify that is called Salsa. Comes out of Google. Who in the crowd has heard of Salsa or is using Salsa today? Actually, who's using Salsa today? One person only. OK, so maybe worthwhile doing an introduction. So Salsa is a way for the organization to reduce the risk from using internal sources, a set of best practices on how to secure internal sources, external sources as well, and also vendors as well. So there's a whole range of things that Salsa says, this is what you can do to secure your builds. Let's look at them together. These ideas come from all of these frameworks put together, we're going to talk about how we can secure our builds, our source code, our activities. Step number one. Okay. I'm a developer. I want to secure my source code. I know I need to use open source. I can't escape using open source because whatever, who's not using public libraries today? But maybe there are two libraries that do the exact same thing. Maybe I'm a Java developer. I want to use Redis, and I can use Lettuce, or I can use Jedis. Maybe I'm a Python developer that wants to create an API. I have so many options in front of my eyes. Which one should I use? Which one is the most secure? I don't know. I can go on GitHub and look at the stars. But is there not a better way? There is a better way. It's called OpenSSF scorecards. These are being adopted by a number of projects right now in this space. This is a way for you to say, as a maintainer of an open source project, this is the list of things that I do that secure my builds. For example, my library, the library that we maintain, has a 4 eyes PR rule. So whenever somebody creates a PR, somebody else needs to merge a PR. So you can choose a library that has a higher score on this OpenSSF scorecard. That is a good indication. Or you can go to a set of suppliers, Google being one, that what they do the selection for you. So they will choose a subset of all the libraries available and recommend the ones that pass the security scanning and security test. It's very advanced. We see that scorecards results, so as we said, scorecards contain all of these heuristics. My artifact is signed. I use code reviews. We use CI best practices. The numbers are not super high yet, right? So I still need to secure external libraries. What do you do as a company, as an organization? If I use external libraries, I can, for example, run static application security testing on the source code itself. I can run dynamic application security testing on the source code itself. I can run software that will protect me from dependency confusion. I can run a piece of software in my CI that says, you're using a library that has a name very similar to another library that has way more users. Are you sure that you're not being tricked into using the wrong library here? So you can have these checks in your CI that helps you protect me from this, right? Semantic versioning as well is another important feature that you have. You can go even more advanced, and this is what we do, for example, in my company, but in lots of companies. We have internal mirrors of external third parties. So we don't just, whenever we build our software, we don't go on GitHub and say we're just going to download the library directly. We mirror the library in our own internal systems, and then we download from our systems, so that we always have a copy, such as if somebody decides to delete the library, I can still build my application because I'm downloading from local. There are commercial tools that allow you to do it, Artifactory from JFrog. There are open source tools that allow you to do it as well. You can have your own repositories internally. In general, you can run software composition analysis as well. So if you're, for example, using a Docker container that you're downloading from dockerhub.com, you sort of know what it's doing, but you're not sure about it. Well, you can run some scan on the container you're downloading from and making sure that container has libraries that you approve, that you know what they're doing as well. You know what the container is doing behind the scenes. There's a number of things you can do around all of this as well. We can look at SBOMs. SBOMs are by far the most popular way of thinking about this, supply chain security. Now, you're building, I'm sure most of you are building your stuff in containers. Who is also creating SBOMs for their containers or checking SBOMs from external suppliers? One person, 2 people, 3 people, 4. I feel so like 10% of the room maybe. Like, it's very small, maybe less than that. Very small percentage, but this is super important. So this is the takeaway if you've never used it before. What is an SBOM? Software bill of materials. Is effectively a JSON. It's a piece of JSON that says, inside this container, these are the libraries, these are the files, this is what we're using. SBOM are super important because they allow you to verify from an external third party or internally within the company what you're building and what you're running. Let's just make it real here. Let's just say that we have another log4j issue in 2025, different library, same thing happening. We're working companies where we have hundreds, if not thousands, of containers running in our production systems. How do we know which one is running this new log4j? Well, we can't, right? Unless we have an SBOM. The SBOM will say, This is what the container is running. These are what the libraries are running, so I can go and check it. So now we know which ones need to be patched. ASBOM, really popular, really getting really, really big. Also, other basic stuff on GitHub. Who's not doing it, I think, in 2025? But still, having branch policies on your GitHub, having signed commits to your GitHub as well, having SSH keys, secure repositories, all of this is super standard. But as we learn, this is really, really important. In a similar context, looking at source code and AI as well. How do we secure source code coming from AI assistant? Usual way, we treat that as external source code. Why? Because pretty much all the research we've seen so far tells us two things. People who use AI assistant create source code that is, on average, less secure than source code that has been created without the assistant, and people that create source code are more likely to believe that their source code is more secure. So you're tricked into this. And maybe over time, this result will change with agents and AI assistants getting better and better. But in 2025, you still have to be really, really careful with the source code generated by AI assistants. And all the tricks we've heard about this, right? So code that comes from the AI assistant, same risk profile of source code that has been generated on open source. It's not your own source code. Especially if you're using something like Claude, and you're asking the agent to create large amounts of source code. If you're asking the agent to create this maybe function for me, less of a risk. If you're asking the agent to create these 50,000 line set of 200 files, I don't know what's in there, that is more high risk, I think. Okay, so phase one is securing the source. Phase two, let's secure the build environment, right? We said we don't want to carry the same risk that perhaps SolarWinds or companies like that had. We want to make sure that our build environment is secure. So we have to treat our build environment as production. This is another takeaway. If you want to build securely, treat the build environment as production. Have immutable builds, they can change. Use ephemeral workers that can be compromised. Make sure that you can protect the build cache, another type of attack, pretty recent as well. Make sure that you include security scanning during the build as well. All the pipelines should be defined as code in a way that you can prove what has been created, repeat what has been created. This is why Salsa has this notion of something very specific, and it took me a while to understand it, but is provenance. Provenance is another important topic we have here. Provenance is, definition is a bit complex, but the thing is, provenance is typically a JSON file that says, we had some source code, it was built into an artifact in this way, and we can prove it, because this JSON proves that the build process was done correctly in the right way. So the builder can be trusted to have faithfully recorded the provenance, okay? This is a good place because consumers can prove that the artifact that has been generated as they expect it to be, as they want it to be, okay? So it's verifiable provenance is a part of all of these frameworks across the space. We want to also sign the artifacts and secure the repository of the artifacts, right? Your artifactory, your local mirrors, whatever you're using locally, make sure that it's secure as well. And validate all of this. And also, after you validated, you signed your code, at deployment time, well, validate the signage now. You sign the artifact, you build your SBOM, you deploy everything in production. Once it's being deployed, deployment process should say, okay, 1, I verify the signage. 2, I verify the provenance. 3, I verify the SBOM compliance as well. I build inventories as well. So these are steps that help you secure in the process, right? Sign it more, add more content, use Salsa that helps you building more and more. But is it over at deployment time? No, it is not over yet. Why? Because we have a whole process of updating it. 20% of libraries that were maintained in 2023 are no longer, Java and JavaScript, are no longer maintained today. Meaning that in 2023, you've used a library in your source code, and you haven't been updating it, or maybe you want to update it, but the library is just not being maintained anymore, so there are no new updates because nobody's looking after that. That is a problem you want to be on top of. You want to know exactly what is the risk profile you're exposing yourself, both as a team and as well as a company. In our company, for example, what we do is that at a company level, we have a set of policies that say, no matter the team, no matter technology, no matter the language you're using, you can't have on our production code that is using libraries that have not been updated in the past 3 days, 3 months, 3 weeks. So we check this at a company level. These are policies and checks that happen at the company level. This is not a team cannot override that. We define as a policy and then we implement that. And we can run continuous scanning of deployed code as well to make sure that if we have another big library affecting lots of applications, I can catch exactly application in all the thousands and thousands of containers that we run every day to ensure that there's no library that has been affected or vulnerable library there. Overall, maybe another takeaway, another thing to think about today is really establishing a corporate supply chain security program. This is the thing, okay? This is the thing. So my friend Alexander earlier said that I need to be inspiring in this talk. So I want to inspire you in doing one thing, which is build a program. So this risk is getting bigger and bigger. You can't just use libraries as they come from GitHub or open source. You have to make sure that you're secure. And you want to do this not at a team level. You don't want to do this at a dev level. You want to do this at the org level. As tech leads, as CTOs, as VP of engineering, you have to build this thing, okay? There's complexity with it, though. So how do we build something that is so complex? How do we make sure that is something that is suitable? How do we do it? Who can help us building it? Can we do, like, we said it's a team effort, right? So we need a platform team that does it. Who is working in a company today that has a platform team or a DevOps team that is looking after these concerns? Can you raise your hands? Okay, so this is maybe 20% of people here. So this is super important. As a company policy, this is what you want to have, right? You want to have a platform team that is focused, that builds all of these controls for you, such as you don't have to repeat this across all the different product teams that are building upon the platform. The problem is, though, with platform teams, historically, is the fact that you don't want to constrain your developers. You want to give them a golden path. You want to be able to say, okay, guys, here is how you can do your thing in the easiest possible way. If you don't want to do it, you cannot do it, but you still need to conform to our policies, right? So, as I said, the example is super easy. We, as an organization, establish a set of policies that say you need to update you cannot have a library with a vulnerability for more than 30 days as a company policy. We implement that as a CD check, or we implement that in the production environment. That is, you cannot escape that. We run that, so you cannot escape that. But you as a team can decide to update your libraries using our standard mass update tool that applies to everybody, or you can say, I don't want your mass PR tool because maybe I'm different, I'm special, I'm going to do my own thing. This is really important. As a platform team, we don't want to go there and force people to use our tooling our ways. We just want to define a golden path that they are encouraged to follow, because if they follow and use, that is the path of least resistance. But at the same time, if they want to do their own thing, they're still in compliance with our policies. We have to be aware, in other words, of the cost of using the best tool to solve the problem. We don't want to have, as we said a million times, a company with 100 people and 20 programming languages. It's crazy. We want to have one company with 100 people and maybe 1 or 2 programming languages with it. Okay, so we're in the last 3 minutes of our talk, so I want to leave you with some takeaways, okay? The first takeaway is maybe more of a reflection of where we are as an industry. The big problem that has been coming up over the past years can be summed up as open source maintainers not being suppliers. That is the big problem, okay? The big problem is that people are finding a very easy time exploiting libraries that are maintained by people that are not paid, volunteers online, because they're not being paid, right? And so what do we do? It's very hard for us to go to the maintainer of a library and say, hey, I'm a big enterprise that makes billions of pounds or dollars or euros, and can you please implement the security policy in your library? You very small maintainer in a corner, maybe somewhere else on the planet. All of this is unsustainable, right? So there's no incentive for them to do it. So this is the industry that we created as a whole. This is what it is. Like, open source libraries maintained by maintainers who are not being paid, used by companies that make billions, and having vulnerabilities is clearly the best and easiest path to insert themselves. So what is the result of all of this, the gap? What we've seen at the beginning of the talk, regulation. Government are coming in and saying, there's too much risk here, you can't just use this library. So what do? We created a whole industry of other open source tooling and commercial tools that are there for no other reasons except for securing stuff that comes from open source, because we can't trust it anymore. In the same way, we could have also gone the other way and say, hey, here is some money for maintainers to maintain their projects and adopt all the standards we want them to adopt. But the industry didn't do that, right? The industry said, we're building a set of tools that are commercial in nature that help us securing from open source. This is the big takeaway. Open source maintainers are not suppliers. So this was a bit of a 35-minute journey on supply chain security. I hope I was able to interest you as well and maybe inspire you to look after your source code in a different way, knowing all the risk and knowing how complex some of these attacks are as well. The takeaways are, number one, supply chain security is a complex thing, and it's a very holistic way you have to think about that. You can use platform teams to define policies using some of the best practices that I showed before, and these platform teams can help you building this. We know there's clear ROI. There's return on investment on this, because we've seen that from the guidance that we got from the DevOps report saying that companies that are good at this make more money. We know that we can look at all of this. We know that we just need to establish a mature open source culture, but we can do it. That was my talk, folks. Thank you very much for coming. I'm not sure if we have time for questions now. We want to...
So technically, we're supposed to go on break, but we have time for one question. Raise your hand so I can see you if you have a question. If not, come on closer so they can see you. Find him during the break. He is here and he can answer your questions. So you have 10 minutes. Be back here on time, please. Thank you.
Thanks, folks. Thank you.